31. I mean, total 31 students are there. Okay. So means we only have 24 or 22 people who have joined. Maybe others should. I mean, today it is the first day of live online class, so you should make sure that you join by 9:30 or whatever is the time of the class. So that is why I will be sharing link 10 minutes before the class will begin, so as to enable you to join the class timely. Because if you people will keep on joining in between, that causes a pop-up window, and then I have to I will be distracting from the class. So anyway, now what I uh, uh, recommend you is that in the chat box you write down your roll numbers, so that that will be your formal or sort of attendance for today's class. So everyone should write down their respective full roll number. Full roll number means CUHP 19 UG pass blah blah blah, whatever it is. Okay, fine. And now let us begin with the class formally. So as I was talking already, that this course is on digital electronics, and digital electronics is not anything I would say unknown to anyone. Whatever we have been doing nowadays, with the help of any gadget, electronic gadget, most of them are now based upon digital electronics. Say the cameras which we are using, the microphone, the computers, even the networking technology, all is based upon digital electronics. So this uh, digital electronics is a very important component, and that is why we need to understand how the building blocks of this digital technology work. In our last semester, we did a course on programming, and in that course, what we did was we learned how we can program a computer. So there was a language, some computer language. There are actually many ways to program computer. So there is something called a computer language, and by using the language, we can give instructions to computer what all to perform. So that was software part of the digital electronics. In this course, we shall be talking about the hardware part. While giving you the introduction on that previous course on computer programming, um, I just briefly told you that okay, whatever instructions we are giving in the say Fortran language, those instructions actually gets translated into binary numbers, zeros and ones, and those binary numbers are actually understood by computer, and then it executes those binary numbers in the form of some electronic signals, and those electronic signals are then processed inside the processor of your computer, and then those signals are further given as an output to you, and then you can program signals to say analog signals, or analog signals to the binary signals, and so on. So as such, the full digital technology, or all our electronic gadgets are not that simple. I mean, they are very complex. They employs a lot many things. If you think of the full computer system, which is being used right now by all of us in the form of maybe mobile or a laptop, so that itself is a very complex thing. But still, In this course, don't expect that we will be knowing each and everything of what our computers are made up of, how they are working, how is the binary signal being converted into, say, a video signal, audio signal, and so on. No. But here we shall be discussing the fundamental working principles and the building blocks of the digital systems. So let us formally begin with the presentation. So why this digital electronics? I already told you what is the significance of the digital electronics. Almost all the gadgets which we see around, or most of the gadgets, I should say, are based upon digital electronics. Whether it is our computer systems, the communication systems, even the internet which we are using, or mobile communication, they are all digital devices and are based upon the digital signals. Digital displays. This is one simple example of a digital display. I hope you can see the screen. Is everybody able to see the presentation which I am showing on screen?
Yes, sir.
Okay, good.
Yes.
Okay, fine. So digital displays. This is a very simple, primitive type of display, but even the display which you are seeing on your screen, display of your mobile or your laptop, which is as good as some analog signal which we see around us. So that is also actually using the digital form of the signal. So your internet, of course, it is something really interesting to note that there are a lot of things which we see in our gadgets. On, say, for example, your mobile screen, you are able to see the text which is written in, say, English, or image, or you are able to record your audio, you are able to hear sounds. All these signals are analog signals, right? But interesting thing is that on the background, these all signals are made up of zeros and ones. So that is something interesting, and we all should really be fascinated of it. That okay, how those zeros and ones can lead us to such very interesting things happening on our screen. For example, you would see that your screen is able to display various colors, and very beautifully you can capture various colors. How is it possible? I mean, if you click a photograph, then you get all those colors, and the question or interesting part is that those colors are stored somewhere in your digital storage, with the help of your digital camera, that is stored in your digital storage in form of zeros and ones. So there must be a lot of processes going in between which do all these tasks for you. So almost all your gadgets are based upon digital electronics, and there are various other areas. For example, even if you are talking of the things which appears to be not at all related to computers, are actually using computers in one or the other way. For example, your cars. Even in your cars, you have some computer-based system fitted inside, which decides how your car will respond to when you apply brakes, how the fuel will be injected to engine, how music system will work, how, say, for example, anti-lock braking system of your car will work. All those things are done with the help of some uh, computer system fitted inside the car. Then you should not ask me that okay, where is the keyboard of that computer system, or where is the screen of that computer system. Computer system doesn't mean just a keyboard and screen are mandatory. So these processes are not um, to be shown out to the user. So they have already been designed by the manufacturer, and they are properly fitted accordingly. So anyhow, so this is more than sufficient to give you an motivation for study of digital electronics. So this is a very open sea. There is a lot of things which actually can be done with the help of digital electronics, and the coming era is going to be the era of digital systems. So that is why understanding digital systems is very important. As I already told you that digital systems have two major components, or they can be divided into two major components. One is hardware, and this is the set of electronic components which actually uses those which actually stores the voltages in the form of zeros and ones. So in a digital system, you have only two forms of the voltage: low voltage or high voltage. Say for example 0 volt or say 5 volt. So if the voltage is 0 volt, the signal it is called binary zero, and if the voltage is say high or 5 volt, this may be called as binary one. And the second component of the digital systems is the software. So basically, the software component is that programming part. I mean, how to convert those zeros and ones into the signals of our interest, or the signals which we can interpret. For example, if I click a photograph with the help of my camera, the signal is analog signal. Your camera is receiving the light, and you click, and then that light has to be converted into zeros and ones. So that is done with the help of a lot of software, and those zeros and ones, so that's the softwares convert that signal into zeros and ones, and then those zeros and ones are stored in the hardware. And then when you have to view the photograph again, then you click right somewhere with the help of the software, then software access that data and do almost the reverse of it and display the data on your screen. So that is how hardware and software of the digital systems are uh, very key components, and they work almost like hand in hand with each other. So both components are very important. Now we may ask, oh, students are still joining. Subhash Thakur. I just request all of you to join timely. Today I am allowing. Today onwards I won't allow. I mean, now Subhash has come and trying to join. So this distracts the flow of the lecture. So please join timely. Okay. Fine. So let's come back to this. Okay, digital systems. So need for the digital systems. Uh, as you see that things around us, as I already told, that things around us are not digital, they are in the form of analog signals. For example, when I am talking to you, uh, uh, I am producing analog signal. My sound is analog signal, in a sense that when I'm talking, my voice is made up of so many harmonics. It is some sort of a signal. I mean, if I talk in a microphone and then try to plot that signal on, say, uh, oscilloscope, then you can see the form of that signal. So you would see that signal is of some analog form, or that is continuous signal. So uh, that so analog electronics is also there, where I mean, in earlier days most of the electronics used to be in the form of analog signals. So in the analog electronics, what we do is we directly record the signal as such in the form of uh, the voltage, the exact analog voltage, and that signal is continuous. This one figure shows an example of suppose you have a sensor mounted in a room, and that sensor is measuring the temperature of the room. And then suppose you start heating up the room, then what will happen? The temperature of the room will start to rise. This is not exactly for a room, because a room can't go all the way to 80 degrees. It is something like a sensor mounted into a water container, and then we are heating the water container and trying to measure the temperature with the help of the sensor. So what the sensor does, or any sensors do, is that they take a signal and then convert that signal to some voltage. Say for example, in a temperature sensor, what it may do is it may take heat and convert that into voltage. If the temperature rises, the amount of heat going to the sensor also increases, and the voltage will also increase. So that's what is the idea behind the sensor. So in analog systems, what happens is that those voltages are recorded as such in continuous form, and those signals are called analog signals. And what may be the other way is that we note the voltage at one point, then after small interval at some other point, and so on. So this type of signal is called digital or discrete signal. Now, the problem with the analog signals is that we have to make a very precise circuitry. Some small fluctuations in the circuit may cause a lot of disturbances in signal processing. And for example, the performance of resistance. Let us take simple example. If you have resistance in your circuit, then resistance is a function of temperature. Resistance of any material is a function of temperature. It varies with the temperature. So if the temperature changes, what will happen? The performance of your circuit will change because the resistance in the circuit is changing. And because of that, what may happen is there may be some voltage fluctuations in the circuit. So if you are giving some input signal, input analog signal in some specific form, suppose it is a sine wave having some amplitude of say 1 volt, then output signal is coming out of some analog circuit. It is also a sine wave, suppose. And suppose our circuit is an amplifier, then what it will do, say suppose 1 volt signal is being amplified to 2 volt. But because of some changes in temperature, what may happen is the values of say resistance in the circuit may change, and that may affect the output voltage. So signal which was a 2 volt amplitude, it may fluctuate around 2 volt. It may go to something like 2.1 or 1.9 depending upon details of the circuit. Means in analog circuits, the circuits are sensitive to the external factors. Temperature is one such factor. There may be many other factors like impurities in the material of the resistance, and so many other factors. So in terms of these challenges, the analog electronics was not that stable for precise operations. But and then people realized that why not work in terms of digital electronics. And slowly over the coming lectures, you will realize that analog electronics, or sorry, the digital electronics offers a far more stable operation. You should have seen some old radios in your home, or some old music systems which are based upon analog electronics. Those may be having some analog switches. Say volume knob, even for example, is a variable resistance. And you would I don't know how many of you have come across such kind of equipments or devices, but you would realize that those uh, circuits, say for example, that volume knob may get faulty over the time. You may realize that if you change the volume, you may find extra noise because of that knob being rotated. So all those are the challenges. Now you see your mobile phones, even to change volume, you don't have some circuit as such. I mean, you do it with the help of simple switches. So even a single switch can be multifunctional. I mean, you may use same switch to change the volume. You may use same switch to click the photograph. So that is also the great aspect of digital electronics, and this has been possible because of the development in software technology and many other things. So that is these are all the advantages of the digital systems. So fine. I mean, even in digital electronics, there are various forms. So the digital electronics which we use is based upon binary systems. What do we mean by binary systems? Means there are only two states of the circuit. In analog circuit, every voltage has a meaning. So for example, if you're plotting a sine wave in analog circuit, or if you're giving a sine wave signal to an analog circuit, voltage may be say 0 volt, 0 0.1, 0 0.2, 0 0.3, and varying in continuity, not in the steps of 0.1 even. Then it has a continuum of the voltages, typical analog signal or analog circuit. But in binary or digital circuits, with the binary system, there are only two possible states. Either your circuit will be in low voltage mode or it will be in high voltage mode. Low voltage may be something like 0 volt, and high voltage you may say something like, say, 5 volt. So so only two voltages are meaningful for binary systems, either 0 or 5. You may represent them with the binary numbers like 0 and 1. So they are simple in terms, or in the sense that, okay, either your circuit will have 0 volt, so you will say, okay, it is 0. If it will have 1, you will say it is in high state or low state. Any voltage in between is not allowed. Or I'll be showing that in the next slide, that okay, even if the voltage is say 0.1 volt, what will you treat it as? So that is in the next slide. Let me not get into that right now. But yes, what is the advantage of those binary systems is that
सिग्नल नहीं आया क्या?
पता नहीं यार सर कहाँ गए।
ओ भाई, ओ यार, ठीक है। सर कहाँ चले गए भाई? सबका डिजिटल सिस्टम में चल रहा है। डिजिटल सिस्टम में प्रॉब्लम आ गई सर। ओ मन कोट ये की आलसी तेरे। बढ़िया भाई बढ़िया। सर का डिजिटल सिस्टम खराब हो गया अंशु भाई।
बस करो भाई, अगर रिकॉर्डिंग हो रही है तो गए तुम।
सर का नेटवर्क चला गया और क्या बोला हमने।
अंशुल का नेटवर्क भी जा
यस।
रहा है।
यस। क्या गपशप चल रही है भाई बच्चों? What all gupshup is going on? Okay, there was some problem in my network. I don't know what, but I was just I went offline due to some technical problem. So, uh, can you help me know that okay, where did I leave or where I had left the meeting? I was just teaching and teaching without understanding or realizing that I have left the meeting. So where I was on which slide I was there and what I was discussing. What was the last thing you heard from my side?
बाइनरी सिस्टम।
So I am
बाइनरी
showing you
सिस्टम सर।
screen. Okay, binary system. In binary systems, what you heard was this. I mean, the advantages of digital signals, right? So could you hear these points till end? I mean, this is these are the advantages of binary systems, that they are stable, they have capability of memory, their operations are simple to understand. These are all the points which I discussed. So I hope that was clear to you. Is it so? Was it clear till that?
Yes, sir.
Okay, fine. Let us now progress to the next slide. And I would like to inform you that the whole class is recorded. So be mindful of the things. It's okay to do gupshup, but not unnecessary gupshup, right? During the class. So due to technical failure, if there is any problem, you just let me know. I mean, we have a WhatsApp group. You should let me know that, okay, if I mean, I should not get offline, right? Or I should not get out of the meeting. If it happens, you should immediately inform me, and you should stay with patience until the class resumes. It should not happen frequently, but sometimes it can happen. Right. So let's come to the next thing. So what we have seen is that okay, binary systems are very simple, very reliable, and that's the most important thing related to the binary systems. So in analog circuits, we may have any continuous values of the voltages, but in the digital or binary systems, only two values of the voltages are uh, detected. Either it is 0 or it is 1. It doesn't mean 0 means 0 volt and 1 means 1 volt. No. We decide two states of the circuit. Like, okay, if it is between, say, 0 to 1 volt, we will say this is, or the circuit is in low state. So that is where that flexibility comes into picture. Even if the voltage of the circuit is 0 or 0.1, something like 0.8, if it is even fluctuating in some range, say 0 to 1, it will be treated as low voltage, or it will be treated by our software as binary 0. And if the voltage is in between, say somewhere like say 0.3 volt, say somewhere between say 5 volt to say 3.5 volt, so we decide this range, then we will say that circuit is in the high state. So the flexibility is very much there. Any kind of external parameters can't change the voltage by that big amount. There may be small fluctuations, like if there is a variation in resistance with temperature, it can lead to change in voltage from something like say 2 to 2.1, 2.2 volt, maybe 2.5 volt, but not too much. So all that margin is kept in the digital signals. So that is what makes their operation very stable. So I mean, if the voltage is low and we say it is binary 0, and if voltage is high, we say it is binary 1. So this kind of logic is called positive logic. But we may do it other way around as well. I mean, if the voltage is high, say up to 5 volt, we may say it as low or zero, binary zero, and if it is zero or low, then we may say it as binary one. So it is just an interpretation. So that is like inverting the logic. So that is called negative logic. So both can be worked out. There is no problem in this. But yes, conventionally and intuitively convenient may be the positive logic. Like, okay, low voltage means zero, high voltage means one. But okay, that is the main, what I would say, the advantage of binary signals. There are certain things which are practically associated with the performance of our digital circuits. One thing is, say, switching time. What is the meaning of this switching time? Is that, okay, suppose our binary circuit is having is in the high state, then ideally or theoretically what we expect is that, okay, it should, if it goes from say one state to zero state, it should not take any time. Ideally it should take zero time, but practically that doesn't happen. If you have some voltage, say 5 volt applied to some signal, then it may actually and then you expect it to go to zero, then it may it will practically take some time. So that time is called, say, fall time. We call it as fall time. Say if it goes from so if H is the, say, high voltage, suppose 5 voltage is the reference volt or high voltage, then the time which the signal takes to fall from zero point 0.9 times H, means 0.9 times 5, which is like or 90% of 5 volt, which is something like 4.5 volt, to 1.1% of the low voltage. Suppose it is, I mean, 1.1% of the low voltage. So this time is called the fall time. So there practically is some delay, or there is practically circuit takes some time. This is called switching. This is related to the switching time. So for the faster operation of any device, the switching time should ideally be zero, but practically it is not. And that is where you should realize that the hardware which you get, for example, your microprocessor of your mobile phone or laptop, it operates at certain frequency, something like say 2 gigahertz or something like this. So this gives you the typical speed, that how fast your circuits in your device can operate. So higher is the frequency, faster are your circuit, and of course higher will be the cost. Similarly, there will be something called rise time. So I mean, if you try to change the voltage from 0 to 1 or low to high, then how much time your circuit takes to rise to that value. So this is called fall time and rise time. So this is illustration with the help of signal of 4 volt. So the values have been demonstrated here. So you can get an idea of how we can interpret rise and fall times of a circuit. Okay, I am getting some question from Jyoti. I just saw it. Okay, what Jyoti is asking is that if the range is 2 volt, what we can say it 0 or 1. So 2 volt was just an example. I mean, standard values of voltage which our digital circuits use are like 0 volt and 5 volt. If you are saying that if it is in between, something like say at 2 volt, so our circuits are designed in such a way that we practically won't get 2 volt. Why it happens is because we use our circuits to operate in saturation mode. I don't know if you have studied transistor, but yes, of course, it should have been in your plus two class. So transistor in off state or on state. So off state means no current passing through the transistor circuit. I will be showing in this coming slides the transistor circuits, and then transistor in ones or high state, something like on state, where the transistor is acting like a closed switch. So 2 volt can't be encountered. Either we shall get voltage around 0 volt or at around 5 volt. So somewhere in between it won't get. Now, okay, you may ask, okay, what if I have a voltage of 2 volt and how can I represent it digitally? Maybe that is the question which you are getting. So for getting that kind of conversion, we actually use analog to digital converter. Okay, Abhi Kashyap is asking, sir, in the graph we see that voltage becomes constant at L, means circuit gets switched off. Uh, See, if constant at L, it means circuit, yes, it is in the zero state, means it goes to the, I mean, there is no current through the circuit or the voltage is low, 0 volt, it is close to 0 volt. And there is another state which is called 1 or 5 volt. When it is saturated at, say, 5 volt, it will be also be a straight line or horizontal line. That means the circuit is in high state. So the voltage in analogs, sorry, digital circuits is like, okay, square waves. Either you have zero state or you have one state, low volt or high volt. Now that low volt in itself may have some fluctuations. For 0 volt it may be something like 0, 0.1, 0.3, 0, 0 again, minus 0.1, something like this. All those fluctuations are not at all treated in binary circuits. We say if the voltage is somewhere between say 0 to say 1.1 volt, we will say this is binary 0. If it is somewhere between say 5 and say 3.5 volt, it is binary 1. That's it. So that's the meaning. And any other voltages, if we have to get, or now you may ask, okay, if I take a binary signal, sorry, analog signal of a sine wave going from say 0 to 2 volt, and then 2 to minus 2 volt means a sine wave of 2 volt amplitude. Then how to represent that in the digital case? So in that case, we do it with the help of analog to digital converter. So we no longer see the voltage as such. We convert, say, suppose you have say 1 volt. So we take that 1 volt and convert that 1 volt voltage into some digital signal. We will be doing it in the coming classes, that okay, how to get that voltage converted into some digital signal. So that signal will be in the form of binary numbers. So we will first study the binary numbers, then we will get to know how that is done. So that is the part of the coming coming classes in this course. So uh, I hope that is clear. Fine. So this is rise and fall time. This is what is important. So now let us quickly talk about what are the building blocks of our digital circuits. You should have done it in your plus two class, but here we will be doing a quick overview. The simplest gate is NOT gate. So in binaries or digital circuits, binary digital circuits, these gates play a very important roles, and these are actually the building blocks of any digital circuit. So that's why we need to understand their operation. So these are two ways to define a NOT gates. You can see NOT gate with this symbol as well as with this symbol. So both are equally well. Now, this is the truth table. I am sure you know what is truth table means. It tells you the relation between input and output. So there are only two uh, values in input as well as in output, because we are dealing with the binary circuits. So the input or output both can be either 0 or 1. 0 means low voltage, 1 means high voltage. Now low voltage, I told you, it can be somewhere in between 0 and 1.1 volt or so. Now it depends upon what voltage range you are choosing. It may be like 0 and 12 volt. So standard values are like 0 and 5 volt. So that's why, okay. But we won't say it is 5 volt. We will say output is 1 or 0, means high or low. That's the meaning which we have. We doesn't care about whether it is 4.5 volt, whether it is a 5.1 volt or something like this. We don't have any interest in that. So means the input and output can have only two values, low or high. That's how we represent a NOT operation. You have already done it. Now here is where we can see or understand how we can actually make a NOT gate with the help of a transistor. This is a What kind of transistor is this? This is a PNP transistor with the help of a PNP transistor or NPN. You check it. Okay. Fine. So this is you should have studied the operation of a transistor as a switch. So basically, transistor has various operation regime. So we are here using transistor as a switch. Means transistor either is used as a in switch off state or in switch on state. So what is the idea? In simple language, let me explain the operation of a transistor as a switch for you. So this is the base, this is your emitter, this is the collector. So what happens here is that if you give a high voltage here to your emitter base junction, then what will happen is that this will be forward biased. So this is a NPN transistor. Okay, NPN transistor. So if the voltage here is high, then this will be forward biased. And if it will be forward biased, what will happen is that all the current coming from collector will be able to flow to the emitter. And when we are using transistor in saturation mode, then this transistor will act like a closed switch. If it is high voltage here, it will act like a closed switch. So what will happen? It will be as if a wire has been connected from this point to this point. So what you will find, if voltage here is high, means one, let us say this one, then what will be the voltage here? This is the output voltage. So it is like, okay, we just connected a wire here. So this ground or 0 volt will be connected here. This means the output will be 0. So if the voltage, this is input, this is output. So if input is 1, output will be 0. That's a NOT operation. If it is 0, what will happen? This base emitter junction is not at all biased. So what will happen is the transistor will be in switch off state. Means no current will be able to flow from emitter to collector. So it is as if it is a open switch now. So what will happen? What will be the voltage here? The voltage here won't be 0 because now this has been switched off. So the voltage here will be exactly this value, means VCC or high voltage. So that is how we can understand operation of NOT gate. Means if you give a high voltage at the input, there will be low voltage at the output. If you give a low voltage at input, there will be high voltage at the output. Is this clear? Yes, response from the students. Is the operation of a transistor as a switch clear? Parikshit is saying okay. Anyone else? I need at least 3 responses. Okay, good. So I hope everybody is able to understand. Fine. Let me ask who is sitting where, or if students are really present. Where is Divyanshi? She's joining now. I don't know what is happening. Okay, Adarsh. Okay, Adarsh just responded. And who all are here? Let us check. Arushi, did you get what I was talking? I want to hear response of Arushi. Chat box. You can set yes. You can say yes, no. Then what about Subhash? Subhash, did you get what I just told you? Operation of okay, Subhash is also online. Fine, very good. And then mute your mic. That's okay. You just should type in the chat box. That is sufficient. Tushar, is Tushar there? Tushar is there. Very good. Tushar is there. Yashika is there. Waiting for response from Yashika. Yashika is not there. Is it? Yeah, good. Just a attendance, right? What about Sonali? Sonali is present. Sonali, you got what I was teaching? I mean, operation of this transistor as a switch or as a NOT gate. Okay, it is, yes, sir. It's not attendance. Just, I mean, you just let me know. Did you understand it? I hope you understood. If you didn't understand, please ask question. So, in case you have any question, because sometimes when I am discussing in the PowerPoint presentation, I miss your chat box. So you may unmute your mic and ask your questions. No problem in that. Fine. So that I can clear your doubts. Fine. So that's operation of NOT gate. Now, similarly, AND gate. This is all conventional stuff. You have been doing it from your schools. I don't need to discuss it as such, right? So this is a truth table, Boolean expression. This is called a Boolean expression. This is the circuit symbol. This is truth table. You can understand the operation of a AND gate. This is how we can get AND gate from uh, two transistors. This type of circuits to analyze the operation of digital circuits, or to get the operation of digital circuits on the basis of transistors in the circuit, is called transistor logic. I mean, TTL. We will be doing it in the coming classes as well. But just to give you a quick idea, means if we use only the transistors in the digital circuit to get the digital operation or binary operation, we call that logic as transistor logic. If the components in the circuit are diodes and transistor, we call that DTL, diode transistor logic. So in this way, we may have different types of methods to implement the digital circuits. So the ICs or whatever we are seeing inside our system, even in your mobile chips, you have somehow somewhere all these circuits implemented. And these circuits are implemented in very small area, that there will be typically millions of circuits in the small chip. Just try to imagine the memory card, which can store something like say 16 GB. In 1 centimeter cross 1 centimeter area, you are able to store 16 GB of data. Now try to imagine 1 bit, then 1 byte, then 1 megabyte, 1 kilobyte, 1 gigabyte. So how much zeros and ones are there in 1 gigabyte? And then how much zeros and ones must being stored in your 16 gigabyte of memory card? So this number is just uh, very fascinating, right? So now you can realize how many circuits must have been synthesized in that small chip of 1 centimeter by 1 centimeter. So that's something interesting. So operation of this circuit is simple. I mean, using same idea. Now I will be saying, okay, if A is 1, means this transistor is in closed state, means it is acting like a closed switch. If B is 1, again this transistor is acting like a closed switch. What will be the output? Let us try to understand. Okay, if A is 0, B is 0, both are 0, so this switch is open, this switch is also open. T1 and T2 are all switched off, means these are acting like open switches. So what will be the output here? It will be 0, because it is connected to the ground, and this voltage is not able to reach at this point, right? This voltage will be able to reach here only when we connect a wire directly like this, right? But this is not this is being done with the help of these transistors. So if both the transistors are in off state, the output here will be 0. Similarly, if this is 0, I mean, if B is 0, A is 1, if any one of the transistor is switched on, but still second one is off, the output will also be 0 again. This is true other way around. The output will be only the one only when both are 1. So when A is 1, or A is high voltage, B is high voltage, then this will be a closed switch, this will also be a closed switch, and the voltage here, which you will see, because now a current will flow through this resistance. So voltage here will be equal to I into R, which will be nothing but VCC. Exactly, this is as if this voltage is directly connected here, because both transistors are acting as a closed switch. So that is operation of your AND gate. Similarly, how you can get the operation of OR gate. So this is circuit symbol for OR gate. This is n input OR gate, right? It's not always true. It is not necessary that any OR gate should have only two inputs. So you can have n number of inputs as well. So that's Boolean expression. This is the truth table. How we can realize the OR gate with the help of transistor logic, TTL. So that's the way to obtain the OR operation with the help of transistors. So notice the connections being done here. So this is VCC, this is high voltage. VCC means high voltage, something like 5 volt, or the voltage which you decide to be high as per your binary logic. So if it is 1 or high 5 volt, what will happen? Uh, Output here will be 1 if either of the two transistors is in switch on state. Because if it is switch on, this will connect the voltage here, output will be 1. If it is off, it is on, again the voltage will be connected here, it will be 1. If it is both are 1, again that's the same thing. If both are off, if both are 0, what will happen? Neither this is able to complete the circuit from VCC to this point, nor this transistor is completing the circuit from this to this point. So output will be 0 here. So this completes the OR operation, or how we can get the digital binary circuits, and we can get the binary operation from those circuits. Fine, that is just a quick overview of what we actually do in the digital or binary circuits, what is there inside the binary circuits. I hope I am online. Okay, fine. Yeah. So this is the syllabus, what all we are going to do during this course. So in our first unit, we shall be talking about the difference in, we already have talked about analog and digital circuits. Now, since we have seen the basic operations and or not, now, now the question is, okay, where are these, how are these zeros and ones uh, converted into the numbers which we actually deal with? For example, in decimal number system, we talk of the numbers which is varying from, say, uh, 1 to infinity, and we can have 1 2 3 4, but in binary you have only 0 and 1. So how we can represent something like 10 with the help of binary, or how we can represent 5 with the help of a binary number? For example, we were talking of 2 volt, right? How we can get binary equivalent of that 2 volt? We won't be talking of voltage as such. We are saying, okay, if we have a number called 2 in decimal number system, what will be the corresponding binary equivalent? Then how to convert voltage into the binary form, that will be the next thing which we will be discussing. In second unit, we will be talking about the Boolean algebra, the basics of Boolean algebra, and designing binary circuits. In third unit, we will be talking about data processing units. These are all the components of the digital circuits. Then we will be talking about how logical operations can be performed with the help of binary circuits, addition, subtraction, and all. Then we will be talking about memory elements in the digital circuits, flip flops, and all. Those all are the circuits which are there to retain memory in the digital circuit. Then timers, what are those circuits? Then last unit will be interesting, which will be on microprocessor, how the microprocessor of a computer works. So obviously I'm not, or we are not going to do the working of microprocessor which is there in your mobile phone or the laptops. We will be discussing only the basic idea. I mean, one of the earliest microprocessor, how that was designed to process the digital signals. Because understanding the working of the microprocessor, which are being used in the modern devices, in it is in itself is a full BTech course, or even way beyond it. So we will be understanding the basics. At least we should know how those binary to analog data is processed, how it is created, how it is converted from one form to another. All these things are discussed. So these are the books which I recommend you to go through. The book which I mainly will be following is this book by R.P. Jain. Second one, this is the one which you should have with you. And then another book is this Malvino and Leach. This is also a good book. So I recommend these two books. Maybe I will be keep on switching among these two books depending upon which book suitably describes what contents. Others are these additional books which you may get, or you may refer. I may refer to these books if required. So with this, today's class is over. I would request you to give me a feedback of this live online class. Means how smooth it went on your end. Were you able to listen to the things? Was the screen clear? Were the things okay for you? So just leave your feedback in the chat box, or you can give a audio feedback as well, so that I could get to know that okay, if there were some problems, or we need some improvements, or things were okay, acceptable. Yes, your feedback, please. Oh, Tushar, मजा आ गया. Very good. Okay, it's useful. Okay, I mean, those who feel good is fine. Sir, color and size of the mouse could have been changed. Yes, that's a very important feedback. Actually, the background of the slide was white and mouse is also white. So I will take care of this in the next class. Anyone who faced problem? Subhash, I would like to hear from you. You were calling probably me in between also. Sir, join nahi ho raha hai. Why you were not able to join, or you were busy somewhere and then you got to know that class शुरू हो गया? सुभाष, क्या प्रॉब्लम आ रहा था ज्वाइन करने में? What was the problem? Subhash is there or not? पता नहीं था, ये बोलो, ये मत बोलो ज्वाइन नहीं हो रहा था. So now, I mean, I will be notifying you on the WhatsApp group, also on Google Classroom. You keep following the notifications there. I hope you have timetable. Whenever there will be a class in timetable, I will be taking it, provided there is no technical difficulty or failure on my end. And before the class, something like 10 or 5 minutes before the class, I will be sharing the link. And I will also be telling you one day in advance if there is um, some changes in the schedule. So that will be done in the future, no problem. Everything was okay, so it seems so far so good. Any student, if you face any problem, you can email me or contact me, call me, no problem, so that I can try to find out some way to help you. So that's all for today. Any question from what we discussed? Okay, any technical question which you have from the contents which we discussed today? I am also recording these contents. If the recording comes fine, then I can share it with you. Maybe later on you can watch these, those who may have missed something. But make sure you don't do chit chat during the class, because that will also be there in the recording. Okay, fine. Then that's all for today. Good luck. Have a nice weekend. Take care of yourself. On Monday, we will be having another class. Okay, bye.